Okay? And in your textbooks, page 323. This is a really nice example in that it communicates more accurately what a slope actually means. Because right now, slope to us just means how steep a line is, or how much effort Carl has to put in to go and see his beloved Penelope. Okay? This example talks more about the real under or meaning of a slope. Okay? At least in this case. The Brentwood Regatta in Mill Bay, BC is the largest junior rowing regatta hosted by a single school in North America. I hope I'm saying that right. Regatta?
Yeah.
Regatta?
It's regatta.
Regatta, okay. The races are all 1,500 meters in length, so a kilometer and a half. The graph shows the approximate times at the 500 meter mark and the 1,000 meter mark for one of the boys' races. And if you're watching on YouTube and you don't have the graph in front of you, there's a dot at 85,500. Okay, so at 85 seconds they went 500 meters. And then there's another dot at 180 seconds they went 1,000 meters. So those are the two dots that are on the graph. Okay, is that slope positive or negative?
Positive.
It's positive slope. Okay, good. They ask us to determine the average rate of change for this portion of the race. What? Determine the average rate of change. What do we do? Without looking at the answer.
Distance over time.
Distance over time?
I think so.
Okay.
No, oh no.
No, you
No?
It'd be your final minus your initial, right?
Change in distance over change in time. That's average rate. We also call that, in science, we call that speed.
Oh.
How much distance did you gain in compared to how much time it took you to gain that distance? That's a really fancy way of saying how fast is the thing going. Right? You understand? How much distance did you gain in relation to how long did it take you? So between here and Chetwynd is roughly 8 kilometers. If it took you 5 hours, would you have a high average speed or a low average speed? Low, or a low average rate of change, maybe. Right? A low relationship between how far you went and how long it took you. Because it shouldn't take you that long. However, if it took you an hour, would you be going faster or slower?
Faster.
Faster, right? You would have a higher rate of change, which is another fancy way of saying speed. You had a higher speed. Okay? So in this example, the y-coordinates represent the distance that the guys went at a certain time, and then the x-coordinates represents a time. So if you like, we can change things up a little bit. We can call x and y t and d, just to make it a little more relevant. So now we have d2 minus d1 over t2 minus t1. Okay? So this is 1,000 minus 500 over 180 minus 85. This equals 500 over, thank you. And just give me a decimal approximation to that.
5.3.
5.3. Could you tell me the units? Remember, this is a speed.
Oh, kilometers? Wow. Meters per second.
Meters, right? Because distance was in meters per second. So what does this mean? Well, this means for every second that they travel, how many meters do they go? 5.3 meters. Right? It's a relationship between how much distance they cover and how long it takes them to cover that distance. It's a fancy way of saying how fast are they going. Okay? So, this is important to know. The slope of a distance time graph is the, what did I say? What of that graph, or the what of that line. If I asked you to find the slope, what do you finding realistically
The average speed.
the average speed. Okay? It's the speed of the object in question.